Mark here again, cooking the books with a whole new meaning and bringing y'all that information. So y'all know I've been getting my science on physics, chemistry, photobiology, or you know, biology, microbiology, just science in general, right? So I want to talk about radioactivity and what it is, what it isn't, and why it's important, and how to, like, what to watch out for. So radioactivity is it's a natural process. It's a spontaneous. It's purely probabilistic and spontaneity in the sense that there's no way to predict or to determine exactly what particular atom is going to go through radioactivity. Radioactivity is a decomposition or decomposing of an unstable atom. When an atom is unstable, it decomposes, it decays to attain stability. And that, in a nutshell, is radioactivity. Now, in the process of doing this, it emits what's called mass. And we know that mass times the speed of light is energy. So mass, you know, E equals mc squared. So mass is energy and energy is mass. So when an atom goes through radioactivity, it's secreting, or it is releasing or emitting either a wave or a particle in the form of energy. So we know that also radioactivity is usually connotated or associated or implied with some kind of harmful or noxious toxin that can be very damaging to the nerves, nerve tissue, cells. Again, cellular damage, DNA mutation, cancer. It can cause cancer, obviously. So, but radiation is also positive, right? Because, you know, if you do chemo, that's a form of radiation. So, you know, for medical reasons, radioactivity can be good. But the interesting thing I found about radioactivity is that you and I, we all radioactivate every single day, mainly because of the foods that we eat. Vegetables, fruits, bananas, the oxygen, the air that we breathe, have elements that are radioactive or called radioisotopes. Radioisotopes are versions of an element that is radioactive and therefore can radioactivate. So we as human beings, are living animals, and human beings are also radioactivating every single day. Now, the dangers of radioactivity is this. I named some earlier, but on a human to human, species to species platform, the danger is this. When a person is radioactivated, remember, it's a decomposition of the atom. So the atom is actually disintegration. It's a disintegrating or disintegration of an atom. So the atom is actually disintegrating, it's breaking down. And in so doing, as I said, it secretes and releases energy. And if you're around a person, we're all radioactivating, but the question is, what kind of energy is being released? If you're a positive person, here's the danger. If you're positive, generally have a positive disposition, right? And you are around people who are not, who don't share that same kind of positive energy. So they have more of a, they're operating more in the infrared area of the invisible, of the electromagnetic spectrum. So they're operating on a lower frequency than you are. You're more in the blue, violet, blue area, which is more of a positive energy, and they're on the infrared, which is more a lower frequency energy. You're naturally going to absorb their radioactivating energy, the energy that's being, the radiation that's being emitted, the radiation that's being emitted, you're naturally going to absorb that. The reason why this it's a twofold reason. One, we are designed to be conduits or conductors of electricity. What I mean by that is our cells are set up to allow energy to flow through us. You know, but we have what's called electrolytes, right? These are ionized particles that allow electricity to flow through us. So our cells are naturally designed to serve as electrical conduit. That's one. That's two. This is a twofold. That's one of the twofold reasons why you're going to absorb the radiation that a person is who is radioactive is radiating. So the second part to that is that if you're naturally positive and a person is naturally more in the negative, lower frequency stage, the electron, their electronic structure, which is electrons, are going to naturally be gravitating towards you because you have what's called a high proton count, right? You have a high proton count. Protons are positively charged particles. Electrons are negatively charged particles. So if a person who is radioactivating or is experiencing high radioactivity has a negatively or resides more in the low end of the spectrum, which is a low frequency, you're going to naturally attract their negative energy because of the opposite attracts concept in physics, right? A negative electron and a positive protons will always attract because that's the laws of physics. Opposites attract. A positive and a negative will attract. Like, you know, magnets. We know that a positive and a negative will attract, while two of the same sign, positive and positive, is going to repel. So two of the same signs will repel, two of the opposite will attract. So if you're more in the positive end of the spectrum and somebody resides more in the lower end of the spectrum, they're naturally going to be giving off a negative vibe anyway. But if they're radioactivating, which means the reason why a person, you could be negative and not necessarily radioactivating on a high degree. A person who's radioactivating on a high degree, it means that they don't have enough chemical bonds. Their chemical bond is not strong enough to hold the atom together, and therefore the atom is decomposing, right? And you're naturally going to take that in for those twofold reasons. One, you're highly positively charged. You're going to attract their negative electromagnetic energy. And two, like I said, your cells are set up as electrical conduits. So currents can flow through us easily. Current flow through us extremely easily. We're conductors. So for those twofold reasons, you want to make sure you got, this is why it's so important to guard your energy field. It's very, very, very important because one, radioactivity is a probabilistic occurrence. There's no way to particularly pinpoint exactly what particular atom is going to decay. So also remember this, when an atom is decaying, not only is it seeking to gain to a stable state, it's also going through what's called transmutation within the nuclei. So there's a change going on within. So when an atom decays, right, the original atom is changed. Case in point, uranium-238, when it goes through a decay, it becomes thorium. Thorium, I believe, 235, right? Hydrogen becomes helium. Right, hydrogen becomes helium. And so it's important that you understand that when a person goes through radioactivity over a period of time, they're changing. This is why sometimes if you don't see someone, let's say for several years go by and you run into somebody you haven't seen in a long time, you're like, wow, you're a totally different person. Or you could be with somebody and over the years you said, man, I met you this way, and 3-4 years later you're like a whole new person. People, we change. We naturally change as a result of radioactivity. Radioactivity is a part of evolution, and it changes elements. That if you study radioactivity, the cornerstone or a bedrock tenet of radioactivity is that an element that goes to, that radioactivates produces daughter atoms, which are new atoms, and the original atom changes because it loses for instance, there's 3 types of radioactivity. There's beta, alpha, and gamma. During beta, there's a transmutation, actual changing, okay, of the nuclei. And the example I gave you was in hydrogen. When hydrogen goes through radioactivity, it becomes helium. And uranium, when uranium goes through radioactivity, it becomes thorium, right? Thorium-235. And the reason for that is because the nuclei loses, right, it loses a proton. It loses a proton. So the proton count, for instance, a simpler explanation, one that's easier for me to articulate. What is it? Carbon. Carbon has 6 protons. If it goes through radioactivity and it gains a proton, it becomes nitrogen. So during radioactivity, two things can happen. It can lose or it can gain. So if it captures a proton, it becomes nitrogen. So carbon-14, which has 6 protons, now has 7. And it's no longer carbon. It's now nitrogen. If you go to the periodic table and you study that, you'll understand it. So what I'm trying to say, I say all that to say this. You and I are made of 4 fundamental elements: carbon, hydrogen, nitrogen, oxygen. So many more. There's way more elements that we're constructed and structured of and by. But I'm just giving you the 4 basic, right? In terms of our DNA, we have all these elements that, you know, uranium is within our body. It passes through us in our waste or through our hair. But all these different elements we have within us, right? We have all these elements within our as our composition. So it's important to understand that if you understand that carbon changes to nitrogen, hydrogen changes to helium, uranium changes to thorium, based off changes in the nuclei, which is the atomic nuclei is the center of the atom. So what I'm trying to say is that when people radioactivate, which we naturally do, over a period of time, this is where evolution comes in. Over a period of time, people change. People change because their chemical structure is constantly, or excuse me, not constantly, but their chemical structure is changing over a length of time, depending on their level of radioactivity. And radioactivity, again, it's spontaneity, it's probabilistic, it's totally chance. So there's no way to pinpoint exactly. What you can do is predict how the behavior of atoms. You can predict what kind of change there will be, but you can't predict exactly when. So keep it's important to understand these things so that you can understand how to guard your energy and guard your and shield yourself, because people, if a person ain't taking care of themselves, like knowing this information so that they can take care of themselves, they're vulnerable to this. They're susceptible. And 9 out of 10 times, they're going to be victim of this science. Remember, E equals MC squared. Out of that came the atomic bomb. Always remember that. E equals MC squared. Out of that came the atomic bomb, which killed over 500,000 people in Japan, Hiroshima. So in World War II. So my thing is, keep that in mind. Out of science, we get real, tangible, material, historical, life-altering, world-changing consequences and effects. So if you don't know the science on a micro, not on a macro or a global, but on an individual scale, you're being affected by the science, and it will destroy you if you're not aware of it. So till next time, y'all know what I'm gonna be doing: cooking the books, bringing the info. Peace.